Hello, my name is Matt. I am working on a tool diameter offset modification for the Carvera C1 desktop CNC milling machine. It's a great machine. It's low cost for a CNC milling machine, and it comes with an ATC, which makes it really capable at its small size. It's fairly reliable and accurate for what it is, and I really like this machine. You can equip it with a fourth axis, and there are a whole bunch of other interesting features that come sort of out of the box with the machine. Uh, Along with that, there's a very active community and a very active group of people who will mod this machine. One of the prominent mods that really kicked the community off was the Carvera Touch Probe mod by Faye. And this mod was really important because what it allowed you to do was to very accurately indicate a part. And before this, the Carvera did come with an XY probe that was kind of rudimentary, but it really didn't allow you to indicate parts in quite the same way that this modification allows you to do. So, one of the real interesting features about this modification is that it comes with a very inexpensive probe that replicates the functionality of something much more expensive like this Renishaw, for instance, that you would see on a professional VMC. And you can source this probe on Amazon or Alibaba, but it really just allowed a lot of people access to this sort of higher functionality in CNC machining. And so because that happened, that really got me thinking about other modifications that would replicate the higher level functions of VMC machines. And the one that really stuck out to me or came to mind was the ability to account for tool diameter offsets, which is really important in modern machining. So for instance, when you're taking a finishing pass or a spring pass, what you're trying to do is to make that final surface hit the exact tolerance that you're interested in. And in order to do that properly, you really need to know the diameter of this bit. And on a professional machine, that's a really important thing to be able to do. And so that same company, Renishaw, who makes these professional 3D probes, also will account for that offset by using a tool like this. And what this tool will do is as you bring it down, it'll give you the length offset. But if you hit it from the side, it'll give you the diameter offset. And when you have a bit like the shell mill, for instance, where you're actually setting the teeth in that bit, there's really no guarantee that you're going to make the diameter perfect. And therefore, measuring it every time will help you do a couple of things. It'll help you account for wear, but it'll account for the variances that you might have actually incurred by putting that bit in there. And to be honest with you, no bit is actually perfect. From the manufacturer, they don't come out in such a way where the diameter is always nominal. And the bit manufacturers are really trying to make the bits sharp and will kind of rely on the machine itself to account for the offsets and to make things accurate. So let's see. So as it stands, the company that produces this very low cost 3D probe had also just recently come out with a kit that allows you to modify it and turn it into a low-cost tool diameter offset sensor. And so I really was interested in taking advantage of this and quickly moved onto purchasing one and just putting it together myself to see, whether this was a direction that I thought the machine could be utilized in. So you can see here, I'm taking the conversion kit and I'm actually performing the conversion. One of the things that you want to look out for is when you pull this back off of the 3D probe, that there's a spring in here you're going to want to keep. And you also want to transfer this rubber seal over to the magnetic base that comes with that conversion kit. Yeah, that's me transferring the thing. And one of the things that you kind of want to look out for when you put this in here is that these set screws are pointy and they're going to fit in this notch here. That notch sort of squishes the O-ring, but also takes advantage of this taper in order to seat down properly. But you don't want to pierce this O-ring with these screws, because if you're ever trying to center this by using the screws, you kind of want to, you don't want to have any squish. So when I was done, one of the things that I started to do was to mess with the electronics. And right here, you're actually seeing the probe port. So there's a MiniFit Junior, a series of MiniFit Junior connectors on this control board. And the one here in red actually deals with probing and tool length offsets. And so on this connector, the gray wire here is the sensing line for the tool length offset. It's a specific GPIO that deals with the TLO sort of on its own. This white one here is actually meant for the probing mechanism, and it is the line that's being taken advantage of for phase mod. This red is power, and I believe it's a 5-volt power that's coming out of here, and these two lines are ground. And so as I was tracing these wires and bringing them up, or tracing them through the bed here, I found myself pretty quickly discovering what was going on with this connector. And as you can see here, we have a ground and a power coming in, and a gray sense line. And that gray sense line is actually being forwarded over here, which is connected to the tool length offset sensor. And this power is also being routed to the wireless probe recharge station. And I'm removing all this stuff. You're actually going to see me remove the entire ATC because I have kind of planned to reformat it a little bit in order to accommodate this new sensor, as you had seen in that hand-drawn picture from before. So here I'm just taking it apart. One of the things that I found out from taking it apart is that there are locator pins in there, and they really they keep that ATC stuck in place, which is good. You want that. But as a preface, Carvera has located this position relative to this tool 6, or this hole right here. So that is programmed relative to anchor point 1. So you have an offset from machine coordinate system, which is anchor 1, to tool 6, this sort of double offset in order to then get the offset for where the tool length sensor is. So there's a lot of kind of backwards or reverse math in order to determine where that is. Here you can see that I'm just kind of working my way around the ATC and getting some DIMMs in order to do a 3D model of it. And here you can see that the tool length offset sensor that comes with the machine actually has a couple different stages on here, and I'm not sure which one it produces the measurement at. This is an interesting one. When I pulled this charging station off of the machine, or off of the ATC, I could see that you had the opportunity to throw the USB cord through there, and I'm kind of saving that for later. But for the time being, I just have the three-dimensional probe hooked up to the bed, and I've changed the configuration file so that it's kind of in the middle of the bed. And that's why I was complaining about all that reverse offset math. I would love to change that at some point. Here you're seeing a replication of M491, which is just a tool length offset command in a different location, and that works fine with the sensor. But the real magic is here after I've messed with the firmware for a little bit to get the G38.6 to work in the X and Y coordinate system, which is something that it doesn't do out of the box. You really need to mess with the firmware in order to be able to do that. So here I could show you that I've messed with the, or that I'm looking at the ATC handler, and that the handler itself really controls the script for taking a tool out of the ATC and then throwing it to the tool length sensor and using G38.6 commands. So here I have some pseudocode where I'm attempting to describe how we might do or add on or extend a diameter offset sequence. And having gone through this, I actually discovered that I was going to need to modify the Z probe file in order to account for X, Y, and Z, because previously these calibration functions just didn't allow for X, Y, and Z throughput, and so I've modified it in the read calibrate and also in the calibrate Z, which are the functions that primarily deal with G38.6. Let's see. So from here, there are a bunch of things that really need to be done. This isn't over by far. I still need to have the spindle be thrown into reverse when the machine is measuring a tool. You don't want the tool to be cutting, and you don't want to miss any flutes. So what a professional machine will do is actually spin the tool in reverse while it's measuring on the tool diameter offset. And you can see on the control board here, I have a pin coming off of the sort of extra or EXT port. I'm going to put this in the reverse port of the spindle controller, which is on the machine. And then in the scripts, have the spindle turn in reverse as it's measuring the tool. And then it gets even more tricky, because at that point, you really need to extend the ATC handler in order to have that calibration sequence, which is most of the pseudocode that I've written, plus probably a little bit more. And then there needs to be some kind of tool table refactoring, because currently the tool table functions in the firmware don't account for diameter offsets and that sort of thing. And then even further beyond that, there needs to be a coordinate offset execution function within the machine. So similar to how you would have a coordinate offset for your G54 or your work coordinates, you're going to need a coordinate offset for the bit. And the post processor may have to play a role in this as well. And so there's just a lot of follow-on work that has to go along with this. But I wanted to provide this update just to give people an idea of what's going on with this mod. Thanks a lot.